Wow, hey, it's already Tuesday. Two for Tuesday. We only get one bell ringer on Tuesday, not two. Come on, just one. One is enough for most of you. One is more than enough for some of you. Anyway, yeah, let's do the bell ringer. Hope you've been selling your pies and donuts and stuff, and we'll do class today. Da 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 do 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 da 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 do do. All right. Da 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 do do do. Hey now. Da da do do. Mr. Kovacs class. It's really fun. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class. He's interested too. It's Mr. Kovacs class. And he's super cool. It's Mr. Kovacs class. Well, I'm thinking of it. Don't forget, we're more than halfway through the first quarter, and I do keep track of your lab credits here on the little chart, okay? And you need 1,200 minutes by the end of quarter four in order to be eligible for the Regents. That's 1,200 minutes of satisfactory lab reports. Lab reports are what count. So the actual turn-ins, the work, is what counts. And if you have 1,200 minutes, right, we'll wind up with about 600 possible minutes this quarter. All right, so let's say if you're like this person right here, who's done half of the minutes, they probably will have 300 by the end of the quarter. Okay? They would need to make sure they get at least 300 each of 4 quarters to get to 1,200. It's just math. All right, let's talk protein.
Monomer, polymer. Monomer, polymer. Monomer, polymer. Monomer, polymer. What's the monomer? What's the polymer? The polymer was protein. The monomers would be amino acids, and that's what we're working towards, learning how amino acids turn into proteins and what proteins do. And proteins, there's a wide variety of proteins, but to make proteins, you have to link amino acids together with what are called peptide bonds, right? You do that through dehydration synthesis. Dehydration synthesis. All right? And there are lots of proteins. Proteins I love because they are the workhorses of cells. They do all of the work, really. But there are lots of different types of proteins. Some are more structural. Some jobs are to carry things like a storage. Some things are supposed to be like receptors to allow hormones and things in. And then the most interesting ones probably are the enzymes. They're the ones that speed up chemical reactions. Right, so proteins, lots of different types of protein. We've already spent time with hemoglobin. What's hemoglobin part of? Good, and then also we've talked about insulin. Insulin, of course, that's right. Insulin moves sugar into and out of cells, or helps to move. We'll talk a little bit about enzymes, okay? What's important to know about proteins, right, is they're amino acids strung together, but what happens to them is they bend and fold on each other. And what's most important about a protein, its most important thing is its shape. The shape of a protein is what makes it able to do its work. Okay? So when you make a protein, you get this chain of amino acids. You have to make sure it folds into the right shape or it's not going to work. Okay? Shapes that are wrong don't work. Shapes that are correct work. It's all about the shape. And there are lots of things that could cause your proteins to unfold or to lose their shape. One is temperature. Really warm temperatures cause proteins to denature, to change their shape. That's one of the reasons why we worry about you if you ever get a fever. We don't want you to get too high. You start denaturing your own proteins. And there are other things too that we'll talk about. Okay, so shape. Hemoglobin has got a globular shape. Its job is to carry oxygen. Collagen has got more long shape. Its job is to provide structure for hair cells and nail cells. 2 different jobs, 2 different shapes. The shape is what's most important. This is keratin, right? Here's insulin. Insulin. Right? Insulin is the key that opens up the door so glucose can get into and out of cells. Insulin, it's got to be the right shape or else the key won't fit.
Here's CTFR. This moves sodium and chlorine ions into and out of cells. If they're not the right shape, they don't move out of there, and that creates a water imbalance between the inside of the cell and the outside of the cell, which leads to all kinds of issues, especially buildup of sticky mucus on the outside of your tissues, especially on the outside of lung tissue, right? So it's shape. If the shape is wrong, it doesn't work. Enzymes are a great example, right? Enzymes speed up chemical reactions. They have to be the right shape for the substrate to fit in them. Shape, it's all about shape. Right? Whether they are hydrolytic enzymes or condensation, dehydration, synthesis enzymes, they've got to be the right shape in order to fit what they're working on. If they don't fit, nothing happens. Enzymes. And there are lots of enzymes that we'll talk about, most of which we know are digestive enzymes, and they're found in various parts of your digestive system. We'll spend some more time with that as we go. But what I want you to get out of today is that proteins have to be the right shape in order to work. If they're not the right shape, they don't work.